Welcome to the channel Learning R is Fun. In the last videos, we got introduced to the Dplyr set of packages, learnt about converting wider data into long form of data and vice versa, using pivot longer and pivot wider. And we also learnt about tables and pipes. Now we will cover Dplyr functions, which are called Dplyr verbs also, in two sessions. Data manipulation functions aim to transform, filter, arrange, group and summarize data as desired. The Dplyr functions can be looked at based on which portion of data they operate on. Filter, slice and arrange. These verbs operate on the rows. Filter subsets rows using column values, whereas slice subsets rows using their positions, that is their row IDs you can say. Arrange arranges rows by column values. Select, rename, mutate and relocate. These operate on columns. Summarize works upon groups of rows. Dplyr functions have some commonalities. They deploy pipes. They operate on tables or data frames as first argument and gives output to the next stage. And finally, they give either a data frame or table. With this background, let's go to RStudio. We have got the script ready for today's session. We will start off by loading Dplyr set of packages. We know empty cars is a data set which comes along with R, and then in that data set row names will be the car names. So we can see that we can copy it into df. Now we can have a look at df. df is having row names as car names and then the various variables starting from mpg, cylinder, etc. Now this row dot names of empty cars will store in row name empty cars, rn empty cars variable, which becomes a vector now. Now we have stored the row names, so there is no problem now. We can convert the df into table using table function. While doing so, we will lose the row names because table does not store the row names, it ignores it. So now that we have done it, now we will go to this statement at serial number 18, where first you assume this operator is a compound assignment operator as I have explained in the slide. Forget that, now you assume it is a simple pipe. Now df is passed on to this function as a first argument. So mutate, the data is df, and then now there is another argument, car name is rn empty cars. That means the row names of the empty cars which is in this vector has to be kept in this car name variable, and that becomes the column, one more column for the df. The last column will be car name. So I am going to select that column first and then the remaining columns 1, 11 after that. So what happens is the same df gets added with one more variable name, car name, is now displayed in a different way. That's all. This is a compound assignment operator. That means whatever happens at the end, that is fed back into the df. That means this is the purpose of this compound assignment operator. So we have understood that there is a pipe and that pipe is a compound pipe, and this df goes here, and from this after adding one more column it goes here. There the rows are, the columns are rearranged, and then the whole thing is fed into the df. Now df has been done the way in which we want. Now you see df contains the car name as the variable column, and then mpg as a column like that. And the car name otherwise would have come in the last, now it has come in the first. Now df is a table, that's why we don't have the row names here. So now that is understood. Now here we have got three different principles applied. One is use of mutate function, another is use of select function, another is use of compound assignment operator. We will move on. We will see some functions which have been deprecated, that means they have been superseded by better functions. function is sample underscore n 5. Here what we are saying, from the left hand side data, make a sample of 5 rows. So this is what we are asking, and from the df tibble it has produced 5 values. Now again we can issue the same command. Now this time different 5 values will come. Mercedes 2 was here, here Mercedes 4, and Ford was not here, now Ford is here. Another function is sample underscore fraction. So instead of giving the number of rows to be taken out of as sample, we can give a proportion. So like 0.2 means total is 10, then you get 2 rows. So we do this, we get 0.2 is corresponding to 6, that means 5 into 6, 30. So we got 6 rows, so the total should be 30, so 32 around 30, so here is 32. So we got the fraction of rows extracted out of the total number of rows. Now these two functions have been replaced by better functions. Now we will see the statement at serial number 27, where df we are passing on to the function called slice. We are giving 1:5 as arguments. Now let's see. This produces first 5 rows. Index number 1, index number 2, index number 3, 4, 5. The first 5 rows are picked up. If you want first row and third row alone, then we can give like this, where we use a concatenation function 1 and 3. So 1 and 3 have been picked up. Now suppose I don't use slice, I simply use df 1:5 and comma. That also produces the same result, like serial number 27 and 30 are same. Then why anybody should bother to use a pipe and slice and all those things? You may be wondering. It is because we will be building a set of statements wherein the left hand side will not be looking very clear like df. It will be a data frame nevertheless, but what comes out as a data frame will not be directly visible. It will be in the memory of the person who is coding, and he knows it's going to be a data frame, it's not going to be stored anywhere. From that he wants to slice. So in such cases, using a slice function explicitly helps the understanding, rather than putting a square bracket at that place and then giving the indices and then comma. Slice will become very clear. Of course, slice is useful for many other purposes, but now in this case, since it appears to be very redundant, so I am explaining this. Now we will pick up first and third rows and all the columns and pass it on through pipe to slice. Then nothing happens, the same results 1 and 3 will be picked up like what we have seen here, the same way we will get here. So the whole purpose of putting a pipe and slice etc. is redundant at this point of time. But as I explained, this whole left hand side will not be visible and clear like what we are seeing now. Now we will move on, we will see a slice underscore max. That means we want maximum. Maximum of what? The variable we have given here. We have given mpg. So that is the miles per gallon. In that column, I want maximum 3 rows. So from miles per gallon is available in the data frame df, which is now a table. So df table is passed on to this function as a first argument, and we are saying n is 3, and we are also telling which is the column. So we get the mpg column maximum values 33.9, 32.4, 30.4. So these 3 values are coming up. We wanted 3, but since the 30.4 is a tie, so we got 4 values. Now instead of maximum, we will ask minimum. We will also use order underscore by argument. Here what happens is, we want to order this by HP. Previously it is MPG, Now it is HP. Previously, we have not explained this MPG as a order underscore by argument. The name of this argument is order underscore by. That is not explicitly written here. So R has understood that and performed the work. Here we are saying specifically order underscore by is HP and N is 4. And we want minimum. Now we will see HP. The minimum HP is 52. Then we are getting 62, 65, 66. Here again there is a tie. Therefore, instead of 4, you are getting 5. Okay. We'll move on. Slice underscore tail. These are all helper functions for slice. Slice underscore tail gives you the last row. We got the last row. Then slice underscore sample. Instead of the previous one, that is here, we have used a deprecated function sample underscore n. Now we can use a function which is proper, which has replaced the previous function. Slice underscore sample. Instead of sample underscore n, we say slice underscore sample. And what is to be sliced? df is to be sliced. So here we are getting almost 9 rows. So 0.3 roughly is 10, but we are getting 9 rows here. Okay. The same thing, now we want to the arrangement of this data according to HP. HP is here. Here the values are all not arranged in a particular fashion. So, but now once you say this time the data is arranged according to HP in the ascending order. If you want descending, you can use this at cell number 50. The same result, but HP is in descending order. So, what has happened here? We have used the slice underscore sample function. We gave this df. We also set the proportion is 0.3. We wanted the data to be arranged, and then that arrangement is to be done in the descending order. Here we will create a df2, which is a data frame of two columns. First column is numbers 1 to 10 and 1 and 2. That means basically 1 and 2 are repeated. Letters, again we are getting first to 10 letters, and then 1 and 2 is repeated. So we get 12 rows basically in this df2. So df2, 12 observations and 2 variables, numbers and LTRS. Now I will ask a distinct df2, so the duplicate should be dropped. So distinct df2, we are seeing only 10 rows. The 1a and 2b once again, which would have been repeated in the df2, they have been dropped. Now we will move on. We will use an important, very useful function, select, which we have already used once. Now select df2 minus 1 means I don't want the first column. Otherwise, I want all the columns in df2. df2 has got 2 columns only. The first column is numbers, NYS, that is here, NYS and LTRS. The NYS has been dropped now. If we use minus 2, then I will be dropping the second column. That means LTRS has been dropped, NYS has come. Now we will see how to rearrange the order of the columns. We have done it once in the first command. We have put car names first, that is 12th column first. We have done that here. Select 12, 1, column 11. So we brought this arrangement here. Now we will see there is car name, cylinder and MPG. In this order I want, and that I want to store in df3. So you can see, so df3 has been made. You can have a look at it. So car name, cylinder and MPG. The way in which we want the ordering has been done. Now we can see again df, we want first 4 columns to be selected. Select. So first 4 columns have been selected without changing of the order. Now without MPG and HP, all other columns I want. So I can do like this. Now we'll select all the columns from cylinder to weight. So this is another way of saying cylinder to weight, all columns have been picked up. Like in sequence operation, we are sequencing the columns. This is another helper function, starts with. So we want df to go into select function, and then the starts with is to be applied. Means whatever starts with C is to be applied. So cylinder and carburetor. So these two have come. Here we can also change the name of the column. So LTRS, we change the name of the column as alphabets. And you can see, but this way what happens is, in DF2 we had only two columns, numbers and letters. And now we change the name, so it has become alphabets. But the NOS is missing here. So whenever you change the names like this, and within the select function you don't mention NOS, then that will not come. What changes you have done, that only will come. So better would be to use rename. If you use rename and then say DF2 is to be renamed, and what is the renaming? NOS has to be changed to numbers. Then all the columns of DF2 will come with the change which you have proposed. And that goes into DF4 now. So DF4, we can have a look at DF4. So NOS has changed numbers and then letters remains as it is. So we got both the rows. Now we have come to the end of this session, and we have seen some important Dplyr functions. We will continue our discussion in the next video. Thanks for watching. Bye from me.